Introduction of Differential Equation by Shinde B.S. Contents. In this topic we are going to see the formation of differential equation, definition of differential equation, types of differential equations, order and degree of differential equations, solution of differential equations, methods for solving first order and first degree differential equation, application of differential equations. We can find an average slope between 2 points, but slope and rate of change. Slope means change in y and change in x. That is, if we plot the curve against the x on x-axis, y-axis from like this, we have to find the slope of this line. Means take the portion, this red portion in between these 2 points, and change in x, and blue portion is the change in y. Ratio of this is called as the change in y upon change in x. That is the slope. If we change in y is denoted by delta y and change in x is denoted by delta x. In this case, this is the change delta y, delta x, and that is the delta x. If we change delta x to 0 and delta y to the 0, then it becomes 0 upon 0. It is non-defined. These terms are tending to 0, not are the equal to 0. Means in that case limit exists, and that such a limit is called as the derivative of that point. That is the slope of the curve. Formation of differential equation. The family of straight line is, we know it is given by y equal to mx, where f is the slope of the line and is passing through the origin in two-dimensional coordinate system, xy coordinate system, passing through the origin with slope m. If we differentiate this, dy by dx equal to y is the derivative of y with respect to x is dy by dx. M is the constant as it x, derivative of x is with respect to x is the 1. Dy by dx equal to y upon x. X equal to dy by dx. It is the differential equation of the first order. In this differential equation, the order of derivative is the 1. Now we define the definition of differential equation. The equation contains derivative term is called as the differential equation. Simply, equation contains the derivative terms is called as the differential equation. Derivative represent the rate of change. There are two types of differential equation. One is the ordinary differential equation, and another one is the partial differential equations. Ordinary differential equation means it contains ordinary derivative, and partial differential equation means it contains partial derivatives. Now differential equation, ordinary differential. There are two types of differential equation. One is the ordinary differential equation, another is the partial differential. In this, today we are going to see the ordinary differential equation. In this ordinary differential, we are first define the differential equation. Differential equation is an equation with function one or more its derivative is called as the function. That is the equation. Differential equation is that equation. It contains dependent variable y and its derivative. Then such a equation is called as the differential equation. Here is the y is the dependent variable, x is the independent, y is the function of x, y dependent, x independent, derivative of y with respect to this term plus y equal to 5x. Then we can get such a equation which contains derivative term is called as the differential equation. Now see the another some examples of differential equation, whether they are differential equation or not. Let us see first equation. First equation is the y double dash plus y dash minus 2y equal to 3, where 3 is the constant, y is the dependent variable, y dash means derivative of y with respect to x, first derivative, y double dash means second derivative of y with respect to x. What is the here in this equation? First derivative and second derivative y appears, hence it is called as the differential equation. And similarly in the second equation there is the dependent variable y and the derivative dy by dx and second order derivative of y with respect to x. Thus here is again first derivative and second derivative appears in this equation. So therefore this equation is called as the differential equation. Now third one. Here is the y dependent y and y inverse and y square. Here is a no any derivative term. Therefore it is a not a differential. This is not a differential equation. It doesn't have differential or derivative component in it. Now fourth one, here is the y is the dependent, y dash is the first derivative of y and y double dash is the second derivative of y. In this it is a not equation because there is a no equality sign, therefore it is a not equation, but this is the expression which contains the derivative term, therefore it is not a, this is not a differential equation, it is not a form of equation, no equal sign even though it has a derivative component in it. Now see the, now we are going to see the order and degree of differential equation. Order of the differential equation is defined as the order is the highest derivative. Order of the highest order derivative is the first derivative or second derivative. Suppose this equation d square y by dx, order is the order of highest order derivative term in the equation is called as the order of differential equation. In this equation y is the dependent variable, dy by dx first derivative of y with respect to x and second derivative of y with respect to x. Here is the highest derivative is the second, on the RHS is x 4x cube and minus 24. Here is the y is the dependent, x is independent. We want derivative dy by dx and second order, in which highest order derivative is the second order derivative, hence it is of second order derivative, second order differential equation of second order. It has only, now the next example, dy by dx equal dy by dx plus y square equal to 5x. It has only the first derivative, so it is called as the first order differential equation. Now the next one, this equation contains y is the dependent variable, x independent, y d square y by dx square, that is the second order derivative of y occurs in this equation. Since this equation is called as the differential equation and highest order of derivative is the 2, hence it is the differential equation of order 2. Now the next equation, this is y is the dependent variable, derivative first derivative of y, third derivative of this y occurs, and second derivative of y is doesn't appear here. Here is the only two derivative, first derivative and third derivative. It is a differential equation, and order of this differential equation is the highest order derivative term is the dq y by dx cube, and the order of differential equation is the 3. Now see the degree. Degree is the exponent of the highest order derivative, that is the power of the highest order derivative. Let's see the example, dy by dx bracket raised to 2 plus y equal to 5 into x raised to 2. The highest derivative is just dy by dx and its power or exponent is 2, so this is the second degree differential equation, and that differential equation free from radical sign, that is the square root, there is no, it is free from radical sign, and degree is simply power of highest order derivative term, first order, second degree order. Now next example, this is the differential equation dq y by dx cube plus dy by dx2 plus y equal to 5x. The highest derivative is the dq y by dx square, but it has no exponent. We actually, this is the dy by dx, its power is the 1, third order derivative its power 1, highest order derivative is the dq y by dx, its power is 1, hence it is of the third order differential and its power is 1, hence it is the third order differential equation with the degree, first degree equation. Solution of differential equation. Solution of differential equation is the relation between the dependent variable and independent variable satisfying the given differential equation is containing as many arbitrary constant as its order. That is the solution of differential is the simple relation between the dependent variable and independent variable according to the arbitrary constant. These are depending on the number of order of derivative order of differential equation. General solution. If the solution of differential equation of nth order contains here one arbitrary constant, then the solution is called as the. If the solution of the differential equation of nth order differential equation contain n arbitrary constant, then it is called as the general solution of the differential equation. If differential equation, this is the differential equation of the second order differential equation. Its solution is the y equal to a cos x minus b sin x, where a and b are the two independent, two arbitrary constants. That is, its solution contains two arbitrary constants a, b, hence it is a general solution. Next equation, next solution, suppose y minus bx is a solution of this equation, but it is not a general solution because it contains only one arbitrary constants. For general solution for this second order differential equation, its solution must contain two arbitrary constants. Now, methods of solving first order and first degree differential equation. There are several methods. First one is the variable separable method, substitution method, homogeneous equation, non-homogeneous equation, linear equation, and Bernoulli's equation. These are the forms of the first order and first degree differential equation. We convert this first order first degree differential equation in this format and we apply the method of solving this. What is the first one? This separation of variables. Separation of variable is a special method to solve some differential equation. That is the first method or basic method to solve the differential equation, that is the variation separation. In this differential equation with a function and one variable is a derivative. That is the, suppose first order differential equation with first degree dy by dx equal to phi. This is the first derivative and its order degree is a 1 and phi xy is the function order. That is the first order first degree equation. In the variable separable method, we have to separate the variable y on one side and x variable on the another side, including dy and dxy. Let us in the next slide. Dy by dx equal to phi xy is the given. Now we have to separate the x and y. Here is the dy and here is the y. We will shift y to the left hand side, then it become dy by y, and we shift dx to right hand side, then it become phi x into dx. Thus dy by y equal to phi x. Here is all the terms of y and all the terms of x. Thus we are getting in the variable separable form. Once we get in variable separable form, on directly integrating we get its solution. Its solution is the log of y and its solution is the phi x square by 2 plus c. This is the, here is the plus c is the arbitrary constant and it is the solution of first order differential equation, hence it is the general solution of first order differential equation. Homogeneous differential equation. First order differential first order first degree differential equation, if is the form of dy by dx equal to f of y by x, then it is called as the homogeneous differential equation. We solve this homogeneous differential equation. First put the y by x equal to v, and using this transformation we are changing here y dependent variable to dependent variable y to v. We are changing dependent variable y to v and keeping x is the independent variable as it is. Differentiating this, we get the differential equation in phi and x, and which is in variable separable form. Let us say phi equal to y by x is the same as y equal to x. Differentiating this with respect to y, dy by dx, and derivative of phi x is the v as it is, derivative of x with respect to x is the 1, and x as it is, derivative of v is the with respect to x is, that is the dv by dx using the product rule. Here we are changing dependent variable y to v. V is a function of x, then we have written dv by dx. Here is the dy by dx equal to v. This dx by dx derivative of x is the with respect to 1, that is the v plus x dv by dx. Put this RHS of dy by dx is the v plus x dv by dx into the first equation, and then we get v plus x dv by dx equal to f of v. Y by x is the v, and then this differential equation, firstly we have given the differential equation in y and x, then now we reduce it in the terms of in the variable v and x. Now separate the variable v on one side and x on another side, which then we get in variable separable form. On integrating with the solution in terms of v and x, and then replace v by yx, we get the solution of the original equation. Thus we are here to see the two methods. One is the variable separable method and homogeneous differential equation of first order and first degree. These are the two types of differential equation. Solving this homogeneous equation by using the substitution of v equal to y by x. Today we are stop here. Thank you.